This presentation explains how Klepsydra SDK is used for encryption algorithms, and in particular, we are going to show an example of benchmarking the Raindoll algorithm. So why is Klepsydra SDK used for algorithm encryption? Klepsydra SDK is interesting in two different scenarios. One is processor-intensive algorithms, like convolutions in artificial intelligence, Kalman filters, matrix multiplication, etc. And in the case of large volumes of data to be processed, either, for example, high-resolution images, or LiDAR data, or IMU data, all these sensors that produce data at a very high rate and in large volumes, Klepsydra SDK can be used to process them in a more efficient way in real time. So, on one hand, processor intensive, on the other hand, large volumes of data. In this particular case, we are going to focus on the processor intensive side, and we are going to show the benchmark we have done with the Raindoll algorithm. For that, we have used Google Benchmarks, which is a C++ tool to measure the performance of certain processing algorithms. We will make use of the standard C++ objects in order to do the benchmarking. So in this case, std vectors, pointers, and randomly generated strings that will be encrypted. The Raindoll algorithm is quite simple. You have a random plain text, and then for the text is divided in smaller blocks, and each block is encrypted using the Raindoll. As simple as that. So how do we do this with the Klepsydra? Klepsydra has one of the tools of the Klepsydra SDK is the streaming API. The streaming API enables acceleration of processor-intensive algorithms. In this case, we're going to show the two main approaches that can be done with the Klepsydra streaming API. So first, what we call the event loop pipelining. In this case, the parallelization is done in a pipeline. So it looks like an assembly line where each part of the algorithm, the algorithm is divided in smaller parts. Each of them is executed in a different event loop. In the case of Raindoll, this is quite straightforward because Raindoll encrypts block by block. So first the first block of 16, then the next blocks, etc. So one way to implement the algorithm with Klepsydra, and this is very simple and simplistic example. The first 16 block is processed by the first event loop, the second 16 block by the second event loop, and so on. So why do this, and what are the benefits? The reason to do this kind of separation is first we have control over the CPU. So we can decide how many cores are dedicated to the encryption. And secondly, the consumption of the CPU reduces. In the case of a pipeline, the CPU consumption tends to reduce quite a lot. And finally, the throughput increases. Because we are processing this in a very fast way, in different cores, the throughput of the application can increase as well. There is, however, another approach, which is oriented to other type of optimization, which is using our data multiplexer parallelization. So the SDK, as you know from other presentations, has the event loop, as we just presented, and also the data multiplexer, which consists of processing the same piece of data in parallel by multiple consumers. In this case, what we are doing is passing the full string to the data multiplexer, and each consumer will process one block. So the first consumer will process the first 16 character block, the second consumer the second 16 block, etc. At the end, there is a requirement to put it all together, so it's a final synchronization, but this is done also by the event loop automatically. At the end of this process, there is a final event loop that performs this optimization, this synchronization. What are the benefits of this approach? First, speed, because we are parallelizing, so the latency for the encryption is very low. The CPU consumption is higher than with the previous example, but also the throughput is higher as well. So in case it depends on the requirement of the user. No, if the user needs reducing power, they can use the event loop oriented parallelization. If the user wants low latency, then the data multiplexer parallelization is a better option. So with this we can obtain this type of benchmarks results. As you can see here, Klepsydra processes data in a more linear way and using all the data resources, all the CPU resources, and it can process up to 4 times with respect to more traditional techniques, 4 times more data in real time. And the implementation remains exactly the same. It's quite simple. The only main change here is that the API of the Raindoll encryption goes from synchronous to asynchronous. So, in conclusion, implementing encryption with Klepsydra has a lot of benefits. First, high efficiency in the execution of the algorithm. So the latency can be low, throughput can be high, the CPU is also low. Secondly, full control of the CPU resources dedicated to encryption. So you don't need to just launch the encryption and use all the resources of the computer, maxing it out, but you decide which resources to use. And finally, with our streaming API, the migration or the integration of existing algorithm is quite low. So it can be achieved in relatively short time. Okay, thank you very much.